I will be discussing finite geometric series, and I'm going to use the two formulas shown, one to find the sum, which is S sub n, and the other to find the term, which is A sub n. For my first example, I'm asked to evaluate geometric series, and if I look at the given information, I see A sub 1, I see A sub 8, and I see R. So with the one that I'm going to use is the sum formula. So I'm going to take my S sub n and replace it with, hold on. So I have S sub n, and I'm going to replace the A sub 1 with what's given, which is -4, times the quantity of 1 minus R, which is 2, raised to the nth power. You don't see n in the list identified by n equals, but you do see it next to this A. So that's A sub 8, and 8 represents my n. So that's what's going to go here. And then I'm going to divide it by 1 minus R. So again, I'm using this formula that I just circled, and the R is 2. Once I simplify this, this really becomes S sub 8 because n is 8. And I have -4 times, and once I simplify 1 minus 2 to the 8th power in a calculator, that becomes -255. All of this is divided by -1, which is 1 minus 2. And now S sub 8, if I further simplify it, is going to be 1020, all divided by -1, which becomes S sub 8 is actually -1020. So what that means is all of the digits that are in all of the terms that's in my geometric series that go from -4 to 512 will actually add up to equal -1020, excuse me. If I was trying to use that same information, but this time I wanted to find the 8th term, I'm going to use this formula that's shown. And with this formula, I need to know my A sub 1, my R, and again, the N. And my N is what I'm trying to find in my direction. So I'm trying to find the 8th term. So I'm just going to substitute in what I know. The N is 8. My A sub 1 is -4. It's times R, which is 2. And I'm raising it to the 8 minus 1 power. If I simplify this, A sub 8 is going to equal -4 times 2 to the 7th power, because 8 minus 1 is 7, and 2 to the 7th power is 128. And then my final answer for A sub 8 would be -512. So we already knew that. It told us that the 8th term was -512. So that's when you're trying to find a specific term. If I want to find the 5th term, I would replace that n with 5. What you want to pay attention to when you are actually calculating this, you do not take -4 and multiply it times 2. That's a common error. You are only raising what's in the parentheses to this power. That's it. Once you get that answer, now you can go back and multiply it times the -4. Sometimes you will be asked to evaluate geometric series using the summation notation or sigma notation. That's what this is. So the way this works is your n is the ending number that you're going to end with. So n is on the top of my summation notation. If I'm literally substituting into the function that's shown over here, then I want to actually start with the number that's shown at the bottom. So this would be my starting or beginning number if I were actually substituting and trying to keep going until I get to term 7. So that's what that means if I was manually substituting. If I'm not manually substituting, but I want to use the formula, then whatever is shown in front of my parentheses, that is my first term. So this is really A sub 1. That's kind of close there. So A sub 1, it is what's located outside of my parentheses. R is what's located inside of my parentheses. So I have enough information now to use my summation notation formula. So S to the n, which is 7, not to the n, s sub n, which is 7, is equal to a sub 1, which is -4, times the quantity of 1 minus r, which we said is 4, and that's raised to the nth power, which is 7. All of this is divided by 1 minus r, and r, again, is 4. Once I simplify this information, I have -4, and then 1 minus 4 to the 7th power is going to be -16,383. And all of this is divided by 1 minus 4, which is -3. So after I finish simplifying everything, put this in the calculator, I end up with S being S sub 7, or the 7th term. I'm sorry, adding all of my terms together, all 7 terms, my answer will be -21,844. So again, what's on the left side of my equal sign tells me if it's an S, that means I've summed all of the terms together. And if it was a sub n, that's telling me to find a specific term, which we're going to do next. But before we do that, I do want to show you that you can use the calculator. And I put the calculator steps over here so you can see it. You can write this down. But if you go to the calculator, you can actually type in your summation notation by going to math. And you can either press 0 or you can just press up, and you'll see the summation notation right here. And that will allow you to put your information in, and you notice I still got the same answer, -21,844. So there are the steps. And now I'm using that same information, but this time I want to find the nth term. And so therefore I'm going to use a different formula. Now, if I'm trying to find the nth term here, what I'm doing is literally, like I said, starting with the beginning number that's shown here, and I want to substitute it into the function that's shown next to my summation notation. And I want to go all the way to the number that's listed here, all the way to term 7. I'm not going to do that for the sake of time, but I'll go ahead and get started. So what I'm doing is taking -4 times 4 raised to, I'm going to start with 1 minus 1. That simplifies down to -4 times 4 to the 0 power, which we know that this becomes 1, and so I'm left with -4. If I go to the next term, -4 times 4, this time I want to go to the second term, but the formula tells me to subtract it by 1. Simplifying it is -4, and then this is 4. My computer is doing something. All right, and then raise this to the first power. Again, I don't multiply -4 times 4. I take what's in the parentheses and raise it to that power first, take that answer, and then that's my final answer. So 4 to the first power is simply 4, and then that 4 times -4 is -16. And I'm going to do 2 more. 4, 4, and then next time I go to the next number, 3 minus 1, which simplifies to -4. And then I have 4 to the second power is equal to, so 4 to the second power is 16. 16 times -4 is -64. And then I'm just going to go down to the 7th one. So you would normally have something here, but -4 times 4, term 7 minus 1, which is the formula. And then so -4 times 4 raised to the 6th power would end up being -16,000, excuse me, 384. So this is what the actual term would be. If I wanted to know what the actual summation would be, I would add all of these numbers up, and it would end up being what the summation notation formula told me it would be, or the sum, finding the sum formula would be. You can also see, this is my last example, where you have directions that ask you to determine the number of terms, because as you can see, we have a partial list of terms, but we don't have all of the information associated with it. So what I do see is this time I have S sub n. So what I'm going to do is take that information and I'm going to substitute it in on the side that has S sub n. So that's negative 97,656 is equal to, well, A sub 1 is my first term. So A sub 1 is negative 1. And now I have 1 minus R. And I don't believe I said it before, but R can be found by taking your second term, dividing it by the first term when we're talking about geometric series, your third term divided by the second term, and so on and so forth. Well, if we divide that, we see negative 5 divided by negative 1 is positive 5, and negative 25 divided by negative 5 is positive 5. So this is our ratio, or common ratio, which is 5. A sub 1 is the first term, which is negative 1. We're trying to determine n, so we don't have that information. So n is what we're trying to find. And we were also given S sub n, which was this information. So now substituting in what I know, 1 minus 5. I don't know n, so we're going to raise it to the nth power, all over 1 minus r, which is 5. And once I simplify that, I just bring down negative 97,656 is equal to negative 1 times the quantity of 1 minus 5 to the nth power, all divided by 1 minus 5, which is negative 4. At this point, now you just want to get rid of the denominator by multiplying both sides by negative 4. So this is also what I do to one side, I do to the other. And so once I simplify this, negative 4 times 97,656 is going to be 390,624. And it's still set equal to negative 1 times quantity of 1 minus 5 to the nth power. I need to get rid of that negative 1 that's out front. And what I do to one side, I do to the other. So this becomes negative 390,624 is equal to 1 minus 5 to the nth power. I'm still trying to get my exponent by itself. And so far I have two things in front of it. So I have to subtract 1 on both sides. And I'm left with negative 390,625 is equal to negative 5 to the nth power. Some of you will try to go ahead and convert to log, but you can't do it yet. You have something in front of your exponent, so let's get rid of that. That's really negative 1, so I'm going to divide both sides by negative 1, which in turn turns this to positive 390,625 is equal to 5 raised to the n power. So now on this side, I have an exponent, and I want to take the inverse, which is a log. So log base 5, and then we're going to go around the equal sign of 390,625 is equal to n. So now I can find n by simply putting this in the calculator. I can go to my calculator and type in math, alpha, math. That's going to give me my log base. And I can put 5 and over to the side, 390,625. And it tells me my answer is 8. So n is 8. That's how many terms that will be in my geometric series in order for my sum of the terms to equal this. All right, so that's it. And I'm going to go ahead and show you the calculator steps again. But if you don't mind, please like and subscribe and have an awesome day.